All right, I'm going to do the question 4 through 8. Justify why the given data is the logarithmic. Use the information about the change of the input, change of the output. All right, so these are my inputs: 2, 4, 8, 16, 32. What did you notice? They're all times by 2, so they're all proportional. What about your outputs? 8, 6, 4, 2, 0. I noticed they're all subtract 2, going 2 minus. This is very specific direction that I want you to know it, and this was on your final exam, I think. Well, something like that. So you have to say something about input and output. So I'm going to say my inputs are proportional. So when inputs are proportional, and please tell me how they're proportional. Times by 2. It's very important that you include specific how your inputs are changing, how your outputs are changing. When inputs are proportionally, the outputs are equally spaced. That's the vocabulary I like to say. Some people say the outputs are equal length output interval, or subtracted by 2, or same like space, anything along the line. This is not always going to be the exact answer, but you have to say how your inputs are times by 2 and your outputs are subtract by 2. For linear and quadratic, you know how we'll say over the equal length interval value, your output, the second difference is constant or something like that. Remember those type of problem? On FRQ, you have to say how over what equal length interval, like +1 or +2 or +3, and how the second differences are the same. Is it +2 or +5? So make sure you have a habit of telling me how they are. Number 5, run the logarithmic regression using the Desmo. Okay, so I'm going to go over here. I'm going to put this data in my Desmo. So go plus table. You should be expert by now, right? So go 2, 4, 8, 16, and 32. Those are your inputs. Output values are 8, 6, 4, 2, 0. I'm going to run the regression. What kind of regression are we doing? We are doing the logarithmic right there. Make sure you have a habit of using the green tab because this log model will be automatically checked. If you use the regular Desmo, it will not be. So always just do that. Alright, so this is what I got. So let's write down. I got f of x is equal to 10 minus 2.88539. Make sure you have a habit of rounding at least 1,000. I like to just write it all out to minimize my mistake. Natural log of x. Another thing, make sure it is same as the generic one that your calculator, your problem wants. Sometimes remember there's like x plus 1 or x plus 2. It's a little different. Then you have to run the custom regression. But this one is not. Number 6, use your store equation Desmo to evaluate f of 6. Okay, so I'm going to go over here. Let's copy my equation down, export it. Instead of f of x, instead of y, I'm going to use f of x. And I'm looking for f of 6. In the next line, I'm going to do f of 6. I got 4.830. Make sure you have round to the thousands and do not skip the 0. You have to put the 0. When in doubt, put more. 4.83007. Okay. Next, number 7. Use your store equation to find the x value and y is 5. I don't need this. I'm going to erase it. The next line, I'm looking for f of x is equal to 5 on the graph. Where are they intersect? This gray dot right here. X value is going to be 5.65685 for number 7. Number 8. If the data were to be plotted on the semi-log plot, which of the following would best describe the shape of the data? All right. So since this is the logarithmic, which of the following would describe the shape of the graph? Okay, I think now I'm looking at it, the questions, it does not make sense. So ignore it. You can't do this because you can't. It should have been the other. If it were to be exponential function, which this is not, you can't do it. So ignore the last one.